Okay. Good morning, my dear students. In the last class, we discussed about the chapter sets. Today, we are going to entering into the new chapter, that is relations and functions. Relations and functions. My dear students, today we are going to discuss about the relations and functions. In daily life, we come across different type of relations, like the relationship between teacher and students, isn't it? The relationship between doctor and patient, and also the relationship between police and thief, the relationship between parents and child, isn't it? In the same way, we have the number of relations in mathematics also. We studied in sets, that is A is a subset of B. This is the relation between these two, that is A and B. That is the set A is a subset of B. The line M is parallel to N. This is the relation. The line M is parallel to N. P is a factor of Q. P is a factor of Q, isn't it? Such relations we see in mathematics, isn't it? Now, my dear students, in these relations we observed, that is the relation formed between two objects, isn't it? Between two objects, ಎರಡು ಆಬ್ಜೆಕ್ಟ್ಗಳ ಮಧ್ಯೆ ನಾವು ರಿಲೇಷನ್ ಅನ್ನೋದನ್ನ ಕಾಣ್ತೀವಿ. Yes. Now we have to define or to study, that is the relation concept. We need here some of the terms, some of the basic concepts in which we have to move. The first one is ordered pair. Ordered pair means the pair of elements. Yes, the pair of elements listed in specific order. That is the pair of elements listed in specific order. Why we call as here specific order? Why we call as? Because of according to some particular order we have to write the ordered pair. We have to write the ordered pair, that is the two elements we have to list according to some particular order or specific order, and separated by a comma and enclosed in a small bracket. Such a ordered pair can be expressed as ordered pair x comma y. Here these are the two elements which are separated by a comma and enclosed in a small bracket. Why we call as that is the specific order? Since here this element x, what we call as first element or first component. This is called as second element or second component. Second element or second component of an ordered pair x comma y. Are you understood? Hence we call as specific, since we give the special position for this element and also for this element. For that is the x, and for y we have to mention, we have to give, that is the called as first element and second element. the position of these two elements, if we interchange the structure of this one, the value of this one changes. That means order of x comma, order pair of x comma y, which is not equal to order pair of y comma x, unless x is equal to y. Isn't it? That means these two are different. That is, order pair x comma y is not equal to order pair y comma x. How, sir? Here consider one of the example, my dear students. Isn't it? Here this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now we want to express here the point 2 comma 3. This is the point 2 comma 3, isn't it? But for 3 comma 2, this is the point 3 comma 2. Here 2 comma 3, which is different from 3 comma 2. That means 2 comma 3, which is not equal to 3 comma 2. Isn't it? Hence here ordered pair x comma y, which is not equal to ordered pair y comma x. Are you understood? Yes. Now we have to move on, my dear students. Equality of ordered pairs, my dear students. Equality of ordered pairs. Equality of ordered pairs. If two ordered pairs are equal, that is ordered pair x comma y, which is equal to ordered pair a comma b. If to say these two ordered pairs are equal, if and only if their corresponding elements are equal, that means ordered pair x comma y is equal to ordered pair a comma b if and only if x is equal to a, that is the corresponding elements are equal. That means first element of the first ordered pair which is equal to the first element of the second ordered pair, that is x is equal to a and y is equal to b, then only we say that is these two ordered pairs are equal. This is an important condition. Once again I repeat, two ordered pairs are equal if and only if the corresponding elements are equal. On this concept, that is the sum of the problems we are going to define, that is the important for the point of examination, for the point of, my dear students, examination. That is the example, if ordered pair x plus 1 comma y minus 2 is equal to ordered pair 3 comma 1, then find the value of x and y ಅಂತ ಪ್ರಶ್ನೆ ಕೇಳಬಹುದು. ಇವೆರಡು ಆರ್ಡರ್ಡ್ ಪೇರ್ ಈಕ್ವಲ್ ಆಗಿದ್ದಾಗ ವಾಟ್ ಆರ್ ದ ವ್ಯಾಲ್ಯೂಸ್ ಆಫ್ ಎಕ್ಸ್ ಅಂಡ್ ವೈ ಅಂತ ಕೇಳಬಹುದು ಮಕ್ಕಳೇ. ಆಗಿದ್ದಾಗ ಸಿಆರ್ ವಿ ನೋ ಆರ್ ವಿ ಹ್ಯಾವ್ two ordered pairs are equal, then corresponding elements are equal, isn't it? That means corresponding elements are equal means here x plus 1 is equal to 3 and y minus 2 is equal to 1 according to the condition of if two ordered pairs are equal, then corresponding elements are equal. From this From this, x is equal to 3 minus 1, that means we transposing plus 1 to RHS, that is the minus 1, it becomes a minus 1. We want to find out the value of x here, and here y is equal to 1 plus 2, that means we transposing minus 2 RHS, it becomes plus 2. From this we can write x is equal to 2 and y is equal to 3, that is these two values of x and y. Yes, are you understood? And also another problem we have to move on, important for the point of examination, my dear students. That is x by 3 ordered pair, x by 3 plus 1, my dear students, comma, y minus 2 by 3, y minus 2 by 3, which is equal to, my dear students, which is equal to ordered pair, I think 5 by 3 comma 1 by 3, 5 by 3 comma 1 by 3, 5 by 3 comma 1 by 3. Here also E given, that is the two ordered pairs are equal. From this we can write the corresponding elements also equal. That means we can write x by 3 plus 1 is equal to 5 by 3 and y minus 2 by 3 which is equal to 1 by 3. Isn't it? Isn't it? From this we can write x by 3 is equal to 5 by 3 minus 1. Yes, we transposed plus 1 to this side, that is the RHS side, since we want here x by 3, that means x, and here also y is equal to 1 by 3 plus 2 by 3. Now to simplify this one, we have to take LCM, since these two are fraction, that means one can be expressed as 1 by 1. Yes, that means this implies x by 3 is equal to 5 minus 3 divided by 3, since the LCM is 3. And here also y is equal to LCM is 3, we can write directly, that is 1 plus 2, since LCM same, that is the denominator of two fractions consisting same number. Now 3 get cancel, isn't it? Isn't it? Yes, that is x is equal to pi minus 3 means how much? That is the 2, and y is equal to 3 by 3, that is equal to how much? 1. These are the two values, that is x is equal to 2 and y is equal to 1. Are you understood? That is the problems which are related to the, that is the, if two ordered pairs are equal, then their corresponding elements are equal. By that concept we can do some of the problems, and also I did here two problems. Yes, we can do any type of problems on this basis. Yes, now we have to move another concept. Now my dear students, that is we have to move another very important operation by using sets, that is Cartesian product of two sets. This is one of the special operation on sets. We learn different operations on sets, maybe union operations, intersection operations, disjoint operations, difference operations, isn't it? This is also another type of operations on sets, but this is special type of operation. With the help of this operation, we can learn the concept of relation, isn't it? Relation. Okay, now what we call that is the Cartesian product of two sets. My dear students, let A and B be two sets. A and B be two sets. The Cartesian product of these two sets, the Cartesian product of these two sets denoted as A cross B. Denoted as A cross B. The meaning of A cross B means Cartesian product of two sets, that is the A cross B, and defined as A cross B is equal to set of all ordered pair x comma y. Listen carefully. Set of all ordered pairs x comma y such that x belongs to first set A. That is the in a ordered pair, first element must belongs to the first set A, and second element y belongs to second set B. This is the definition of Cartesian product of two sets. I am going to repeat. The Cartesian product of two sets A and B is denoted as A cross B and defined as set of all ordered pair x comma y such that x belongs to A and y belongs to B. Now we are going to consider example. Consider a set A is equal to 1 comma 2 comma 3 and B is equal to set 4 comma 5. Now I am going to write the Cartesian product of these two sets, that is denoted as A cross B, is equal to defined as set of all ordered pairs, isn't it, such that the first element of an ordered pair must and should belongs to first set A and second element of an ordered pair must and should belongs to set B. That means here 1 must pair with second set elements, that is 4 and 5. Next, the element 2 is formed with the 4 and 5, and also third one, that is the element 3, is formed with 4 and 5. Now we can write set of all ordered pairs as 1 comma 4, 1 comma 5, 2 comma 4, 2 comma 5. These are the set of all ordered pairs. Next one is 3 comma 4, next 3 comma 5. This is what we called A cross B, that is the Cartesian product of these two sets. These are the set of all ordered pairs. In these ordered pairs here, that is the first elements of the ordered pair must and should belongs to set A, isn't it? And the second elements of the ordered pair must and should belongs to the set B. And also, my dear students, B cross A is equal to, see here, B cross A is equal to here set B, that is 4 comma 5 cross set A 1 comma 2 comma 3. Now we can write that is set of all ordered pairs, that is the 4 comma 1, that is the 4 comma 2, 4 comma 3, 5 comma 1, 5 comma 2, 5 comma 3. Are you understood? Are you understood? See here, my dear students, is it A cross B is equal to B cross A? By seeing the ordered pairs of both A cross B and B cross A, is it A cross B is equal to B cross A? One of the point. No, A cross B is not equal to B cross A, since already we know ordered pair x comma y which is not equal to ordered pair y comma x, isn't it? See here, 1 comma 4 which is not equal to 4 comma 1, 1 comma 5 which is not equal to 5 comma 1. Similarly, other ordered pairs also. Therefore, we conclude that A cross B which is not equal to B cross A. Isn't it? Isn't it? Unless under the condition of if A and B are equal sets, we get that is the equal, no doubt. No doubt. Yes, but otherwise this is not possible. Yes, okay. Now that is A cross B which is not equal to B cross A. Are you understood, all of you? Are you understood, all of you? Okay, number of examples we can give, that is finding that is the A cross B or B cross A. A cross B or B cross A. Another example to find out that is the A cross B or B cross C. If P is equal to set of all order P A comma B comma C and Q is equal to set of all ordered pair, that is the R, then he asked to find P cross Q and Q cross P. First one, P cross Q. P cross Q is equal to, we can write set of all ordered pairs. A comma R, am I correct? B comma R, am I correct? C comma R. These are the ordered pairs only. That is, A is related to R. Isn't it? That is, B is formed with the ordered pair, that is the R, and also C. That means we get these are the three ordered pairs in P cross Q. Are you understood? In P cross Q. Next, Q cross P. We get that is the set of all ordered pair. Already we know that is R comma A, R comma B, and the last one is R comma C. Isn't it here P cross Q is equal to Q cross P? No, since ordered pair A comma R which is not equal to ordered pair R comma A, similarly other also. Yes, okay. These are the some of examples on Cartesian product of two sets. Now from this we define some of the important points on Cartesian product of two sets. On Cartesian product of two sets, my dear students. That is the first point. If a set A is empty, or R, B is equal to empty, then what about Cartesian product of these two sets? The Cartesian product of these two sets is also not empty. That means A cross B is also empty. A cross B is also empty. That means any one of the set is empty, then their cross product is also empty. If A is equal to non-empty, that means A is not equal to empty, that means non-empty. Non-empty. That means the set A consisting some elements, consisting few elements, and B is also non-empty. B is also consisting some elements. Are you understood? Then A cross B is also non-empty. Are you understood? A cross B is also non-empty. A ಅನ್ನೋದು consisting some elements and B also consisting some elements, then we get A cross B is also consisting some elements which are in the form of ordered pairs, isn't it? Isn't it? This is the second point we have to write. Third point, if A is finite, B is finite, that is the finite set, already we know, then we get A cross B is also a finite. A cross B nu ಏನಾಗಿರುತ್ತೆ ಅಂದರೆ ಕಾರ್ಟೀಷಿಯನ್ ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ಟೂ ಸೆಟ್ಸ್ ಏನಾಗಿರ್ತದೆ, ಫೈನೈಟೇ ಆಗಿರ್ತದೆ. You want examples? That means if A is finite, A is equal to some elements 1, 2 and B is equal to finites some elements 3, 4, then A cross B we get some of the finite elements. That is the finite set. Since A cross B is also one of the set, A cross B is also one of the set, that is the Cartesian product of two sets is also a set. The elements in this set consisting which are in the form of ordered pairs ಅಲ್ಲಿ ಇರ್ತವೆ. ಅರ್ಥ ಆಯ್ತಾ? That is the third point. Next we have to move on another point. Either A is infinite or B is infinite. That means out of two sets, any one of the set is infinite. Maybe another set that is the finite. Then we get A cross B. That means if A is infinite or B is infinite, any one of the set is infinite, or both are infinite, that is no doubt. A is infinite or B is infinite, then A cross B is also infinite. A cross B is also infinite. ನೋಡಿ, ಎರಡು ಸೆಟ್ಗಳಲ್ಲಿ ಯಾವುದಾದ್ರೂ ಒಂದು ಸೆಟ್ ಇನ್ಫೈನೈಟ್ ಇತ್ತಪ್ಪ ಅಂತಂದ್ರೂ ನಮಗೆ ಬರುವಂತಹ ಕಾರ್ಟೀಷಿಯನ್ ಪ್ರಾಡಕ್ಟ್ ಏನಾಗಿರುತ್ತಪ್ಪ ಅಂತಂದರೆ ಇನ್ಫೈನೈಟ್ ಆಗಿರುತ್ತೆ. ಒಂದು ಇನ್ಫೈನೈಟ್ ಇತ್ತಪ್ಪ ಅಂತಂದರೆ ಅನದರ್ ಒನ್ ಮೇ ಬಿ ಎ ಫೈನೈಟ್, ಏನಾದರೂ ಇರ್ಬೋದು. ಬಟ್ ಅವಾಗ ಎ ಕ್ರಾಸ್ ಬಿ ಅನ್ನೋದು ಏನಾಗಿರುತ್ತಪ್ಪ ಅಂತಂದರೆ ಇನ್ಫೈನೈಟ್ ಆಗಿರುತ್ತೆ. ಎಕ್ಸಾಂಪಲ್ ಬೇಕಾದರೆ ಎ ಈಸ್ ಈಕ್ವಲ್ ಟು ಸೆಟ್ ಅಪ್ ಆಲ್ 1, 2, ಬಿ ಈಸ್ ಈಕ್ವಲ್ ಟು ಇನ್ಫೈನೈಟ್ ಸೆಟ್, ದಟ್ ಮೀನ್ಸ್ 3, 4, 5, 6, so on. Then we can write A cross B as infinite number of ordered pairs. Infinite number of ordered pairs. Yes? Okay. This is the another point, my dear students. Yes? Okay. Now we have to move on about the number of elements of a Cartesian product. Number of elements of a Cartesian product. My dear students, if A has the set A has m elements and set B has n elements, that is we can write n of A is equal to m elements, already we know. N of B is equal to m elements. This means number of elements of set A. This means number of elements of set B. What we call cardinality number of a sets. Cardinality number of a sets. Then how many elements are there in Cartesian product of these two sets? ಅಂತ ಪ್ರಶ್ನೆ ಬಂದಾಗ that means number of elements of A cross B, number of elements of A cross B is n of A into n of B. That means n elements, sorry, this is n elements. N of A into n of B is equal to mn elements. Are you understood? Are you understood? That is the number of elements of Cartesian product of two sets is the formula n of A into n of B, that is equal to mn elements. Therefore, that is n of A cross B, that is the Cartesian product of two sets A and B have elements mn if A as m elements, that is the set A as m elements and set B as n elements. Are you understood? This is the important formula. For example, see here, one of the example. If set A is equal to set up a 1, 2, 3 and set B as 4 elements, then find number of elements of A cross B. He asked like this, find number of elements of A cross B. ಈ ಥರ ಪ್ರಶ್ನೆ ಕೇಳಿದಾಗ first we have to write n of A. n of A is equal to how many elements? 3 elements. And also n of B is given how many elements? 4 elements. Now we want number of elements of A cross B here. Therefore, n of A cross B is equal to n of A into n of B. Isn't it? That is equal to n of A, how many elements? 3 elements. n of B, how many elements? 4 elements. That is 12 elements. That means the Cartesian product of two sets consisting 12 ordered pairs. If he given, that is the set A consisting 3 elements and set B consisting 4 elements, then we get number of elements of a Cartesian product of two sets, that is A and B, is 12. Are you understood this concept? All of you? All of you? Yes? Okay. Now we have to the last concept. See here, by using this problem. If A cross B is equal to set up all ordered pair A comma X, A comma Y, A comma X, A comma Y, B comma X, B comma Y, then find A and B. We know, my dear students, in A cross B, A is one of the set and B is another set. In these ordered pairs, the first element always belongs to the first elements of ordered pair always belongs to the first set A, and the second elements of the ordered pairs always belongs to the second set B. Isn't it? Isn't it? Therefore, A is equal to the set of all first elements of the ordered pairs in A cross B. That is, we can write set of all A comma B. B is equal to the set of all ordered pairs. Isn't it? Here the set of all ordered pairs in A cross B, in which, that is the second elements of the ordered pairs, what we called as that is the set of all elements of B. Isn't it? That can be written as X comma Y. Are you understood? This concept is also very, very important in Cartesian product of two sets. Are you understood? All of you? That is, today we discussed ordered pairs and also Cartesian product of two sets and also some of the important points which are related to the Cartesian product of two sets. If you know these two concepts, then we can learn with clarity, that is what we call as relations. In the next class, we are going to discuss about the relations. Okay, my dear students. Okay, thank you very much.